Yo, what's up, YouTube gang? Freaking squad. Today we're covering the rational root theorem. So let's go ahead and get to it. Rational root theorem, not the most fun thing in the world in my opinion. Not the most elegant and not the most fun. But you know what? The state of Texas tells me that I have to teach you it. And I am going to, because I am legally bound to. So what we have to do here's an example. What we have to do is we have to make a list of all of the possible roots. And what that will look like is all the combinations of the factors of the last term. Really, it's the coefficient of the last term, and it's going to be divided by the factors of the coefficient of the first term. Okay, you need to have this down somewhere, or in your head if you are crazy, if you're crazy good at remembering things. But I would suggest you write it down. So what we're going to do is we're going to list the factors of the last term. So let's do that here. The last term here is 8. So we're going to have plus minus 1, plus minus 2, plus minus 4, and plus minus 8. And yes, you do need all these pesky plus minuses, just because you need the positive and the negative side. And then we're going to write the factors of the first term. So in this case, it's plus minus 1 and plus minus 3. So thankfully, 3 is a prime number, so we don't have that many factors. Now, we have to make the list. So what we're going to do is we're going to take all these... We're going to take all the factors of the last terms, and we're going to divide them all by all of the factors of the first term. So the way I do this is kind of like a combination. I just go down the line. So first we have plus minus 1 over 1, it's 1. Plus minus 2 over 1, plus minus 4 over 1, plus minus 8 over 1. And now I'm going to do everything over 3. So plus minus 1 over 3, plus minus 2 over 3, plus minus 4 over 3, and plus minus 8 over 3. So these are all of the possible roots of this quartic polynomial. So now it's time to shine. After you do this, you just have to go down the line and see which ones work and which ones don't. So that's what I'm going to do. I'm going to start off with positive 1 because that's the easiest. And you're just going to do synthetic division to see if the remainder is 0. Because remember, if the remainder is 0, then we're good. It's a factor. So you bring the 3 down. 1 times 3 is 3, and this is 14. This is going to be 14 here and 20. And then we're going to have 20 here. This adds to 8 and 8. So since I do have a remainder of 0, this is going to be a factor. Okay? So we're just going to put a little check mark here to remember that this is a factor. And now I'm going to have to test 1 again. So because you're going to have factors multiple times, you should make sure after 1 is successful, do it again to the next polynomial. So I'm going to do it to these 4. You don't have to do it to the 5 again. Say you divide it by negative 1. Let's see if we can divide by 1 again. Sorry, if you divide by 1, let's see if you can divide by 1 again. So we're going to bring down the 3, and then 1 times 3 is 3, and you add, this is 17, and this is going to be 17 here, so this is going to be 37, and then this is 45. So 1 doesn't work twice, so it only works once. Now we're going to move on to negative 1 with 3, 14, 20, and 8. That is these numbers, okay? So now we're going to move on. So 3, and this is negative 3. We have 11 here. We have negative 11, and this is 9. So negative 9, this is going to be negative 1. So this doesn't work. Let's move on to 2. So now we're at 2. So we're going to do it with 3, 14, 20, and 8. So we're going to bring down the 3, and this is going to be 6. This is going to be 20. This is going to be 60. This is going to be 80 and 160 and 168, so this really doesn't work. Let's try negative 2. 3, 14, 20, and 8. Bring down the 3. You multiply, you get negative 6. You get 8 here, so negative 16, 4, and then negative 8. So this one does work because we end up with 0 for the remainders. So let's put a check mark here. All right, and now once we hit only 3 numbers in our polynomial, that means our polynomial is now a quadratic. Okay, so we can write this as 3x squared plus 8x plus 4. And we can try to factor this, okay? So you can use whatever factoring method you want, but you should end up with 3x and then x here. So this is going to be 3x and then plus 2 here and then plus 2 here. So if we want to write this in factored form, we get to write these two. So let's go ahead and write these again. And then we have to write these as factors. So if we have a root of 1, this is going to be x minus 1. And we have a root of negative 2, so this is going to be x plus 2. So since we have two x plus 2's, we can actually say that this is x plus 2 squared times x minus 1 times 3x plus 2. And that is going to be your answer. A lot of work for one problem. But I have one more problem to go. I know I'm talking fast, but let's go ahead and let's get to it. So we're going to find all roots of this. Same deal. So we're going to make a list of everything that's all the last term. So all the factors of the last term. So plus minus 1, plus minus 2, 3, 4, 6, and 12. And now so I know this is going to be plus minus 1 and plus minus 5. So let's make a list of all the possible roots. So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. And then I'm going to divide them all by 5. So plus minus 1/5, plus minus 2/5, plus minus 3/5, plus minus 4/5, plus minus 6/5, plus minus 12/5. Just so beautiful to see all of these numbers, right? Now we get to go down the line. So let's start with 1. 5 minus 16 minus 17, 64, and minus 12. So we bring down the 5, you get 5 here. This is negative 11, this is negative 11 here, and this is going to be negative 28. So negative 28. This is going to be 34 and 34, so we're left with 22. So that is not 0, so we're going to continue to negative 1. So 5, negative 16, negative 17, 64, and negative 12. Bring down the 5, get negative 5, and this is going to end up being negative 21. So we have 21 here, and then we're going to have 4. So this becomes negative 4, and this is 60. And this is going to be negative 60. This is negative 72, so that does not work. So let's move on to 2. So 5, negative 16, negative 17, 64, and negative 12. Bring down the 5, 2 times this is 10, and you get negative 6. So you multiply, you get negative 12, and this will end up being negative 29. So here I get, let's see, 58 minus 58, and you get 6, and this is going to be 12, and this is 0. So 2 does work. So now we have to try 2 again with 5, negative 6, 29, and 6. Bring down the 5, and you get, let's see, so that's going to be 10. So this is going to be 4, and then I get 8. Add down, you get negative 21, and you get negative 42, and this is going to be minus 36. So that does not work again. So let's try negative 2. So we have 5, negative 6, negative 29, and 6. So we're going to have the 5, bring down that, and you get negative 10, so negative 16. This gets 32, and you get 3 here, and you get negative 6, and you get 0. So this does work. So after all of this, we end up with 3 numbers. So this is a quadratic. And we're going to factor this. So however you would like to factor this. But this is how I factored it, and hopefully you got the same answer. And since we're finding all the roots, we can find the roots of this quadratic. So it would be x is equal to 1/5. X is equal to 3. and then x is going to be equal to negative 2 and 2 as well. And that is going to be your answer. So that's it for the rational root theorem. I know this video was 10 minutes long, and I felt like I was talking at light speed. Hopefully it helped you, and hope you have a good day.